Hello, this is Mr. Stansbury. I'm going to take you through the notes on axis of symmetry. So at the end of this, you should be able to say, I can find the equation of the axis of symmetry of quadratic functions. Okay, so first thing, the graph of a quadratic function is symmetric about a vertical line called the axis of symmetry. That's this pink dotted line right here. Okay, so basically what that means is that you can take this graph here and fold it along this line. So like this graph right here would fold right on top and map right onto this line right here. Okay, so that is the axis of symmetry. Now, very key and helpful here is that the axis of symmetry, there's an equation to find the axis of symmetry, and that is negative b over 2a. And that's when you have y equals ax squared plus bx plus c. Okay. This should hopefully look a little bit familiar from the quadratic formula. It's actually everything that's not under the radical, because it's x equals negative b plus or minus the square root of all the jibber jabber all over 2a. So there's your negative b over 2a. Okay, so it's again everything from the quadratic except for the root. Okay, let's put that into some practice here. So find the equation of the axis of symmetry. Okay, so basically it's just where's this middle line here. Now, this one here, you're like, wait, I don't have any equations to do that with. But what we can do instead is say, okay, look, here's an x-intercept, there's an x-intercept. We know the axis of symmetry has to be halfway between those two x-intercepts, right down the middle of that, right? So if this is at 0 and that's at 4, halfway from 0 to 4 is going to be 2. So this is going to be y. Sorry, not y, but x equals 2 right there, okay? Because it's x equals negative b. So that equation of the axis of symmetry is always x equals, because it's a vertical line, okay? This one here, look right there, there's our vertex. The axis of symmetry always goes right through the vertex. So this is going to be x equals negative 3 for that one there, okay? And then for C, we want to go halfway between negative 3 and 4. So really this is a distance of 3. This is a distance of 4. From here to here is 3, here to here is 4. So we go 3 plus 4 divided by 2 gives us 3.5. So basically it's 3.5 over. So there's 3 and then another half right here. So then this equation of the axis of symmetry will y equal b, sorry, not y equals, I keep trying that out, but that does not work. X equals 0.5. Okay, that's the equation of the axis of symmetry right there. Okay, let's take a look at 2 more examples, but before that, let's take a quick little comedy break.
He's standing on the ball. He's gonna fall. He's standing on the ball.
All right. Let's take a look at these here. Example 12. Find the equation for the axis of symmetry of these two things here. Big key is we want to remember that x equals negative b over 2a. Okay, so x equals negative, and then I'm going to put b over 2a. So the b is this right here, right? This is a, this is b, and this is c. Okay, so b is negative 6 all over 2a, which is 2. So that gives us minus a negative, so that's going to be positive 6 over 4, which then gives us, what, 3 halves or 1.5. Either one of those is just fine. Okay, so x equals 3 halves or x equals 1.5. Either one of those would work perfect for the axis of symmetry. Okay, and then for b, we got, here's our a. There's nothing there, so, well, it doesn't look like there's anything there, but there's actually a 1 there. So our A is -1, B is -5, C is -3. We don't even need C, but for this here, so we do x equals -5 all over 2 times -1 here. Okay, so we got 5 over -2, which gives us -2.5 is where the axis of symmetry is. Okay? Just to kind of help out, the whole purpose of that is that you now know where the middle of your graph is. And actually, once you know what the x is, you can actually plug the x in for these x's here to figure out what the y coordinate of the vertex is. Okay, but we'll hit that in a little bit. Okay, so if you have any other questions, please feel free to ask. Thanks.